sun moves in the sky, right? The sun rises. Where does the sun rise? Man, you guys are great. It rises in the east and it sets in the west. So, you heard that from where? That's excellent. You heard that this year. That's perfect. So, perfect. So we want to make sure that this is angled towards the sun, right? Does your house move? Okay, house doesn't move. So we have to make sure that we put these on here in a position to get the maximum, to get the most sunlight that we can. The best orientation for us to get the most sunlight, the best is if we're focusing on the south. We're looking at the south, right? Why does that make sense? Why should we focus on the south? Again, I say we're in the northern hemisphere. We're up here. Let's say this is the United States. We're in the northern hemisphere. The sun is going to be shining here, right?
That's north.
North is up here. Is up here. So we want to make sure that we're focusing south, so we get the maximum sunlight, right? That's our best orientation.
So maximum sunlight comes from the south?
Yes, for us, because we're in the northern hemisphere. Then you can go east and west. But the ideal is south, but sometimes we can't get that, so sometimes we have to go east and west. But we don't go north, because if we go north, what's going to happen?
No, it's gonna.
Yeah, we're going to be going totally away from the sun. We won't get the sunlight. Exactly. It's like turning, just like Instructor Carlos here said, if you go north, south, we're getting this way. If you go north, you're literally turning away from the sun. And then, yeah, and if you don't have sunlight, solar doesn't work without sun. You need sunlight. So we want to get that orientation.
So it's like can I see that ball for a second? So if this is north and this is south,
Yep.
south and then east and west.
Okay, that's north, yeah.
So if we go all the way up here, we're not getting any sunlight since the sunlight is coming from here.
That's until
Until you go full scale, it really actually changes. It changes like the direction on which you go through the sun. So if you go around here, you can get some sun. If you go around here, you get the. You said this part was the most sunlight.
yes, so we're going to be focusing towards the sun.
Okay, now I get it. Now I get it. I could understand before. Since the sun is always right here, it just like gives us.
Exactly. So if we go down like that, that's going to give us more light. If we go back like this in the wintertime, it's going to be colder. We're getting less sunlight. All right. But get fuels that you can do at your house to help reduce using fossil fuel. Yeah. Say that loud. Say it loud. So if you're not using a room, you can turn off the lights. Please, Say that again. Recycling? What does recycling, how can recycling help us with the planet? Please.
The plastic is mostly goes to the ocean species.
Exactly. And you know something about plastic? Plastic is made out of and uses
Plastic is made out of plastic. Plastic isn't made out of plastic.
fossil fuels. Did you know that?
No.
Fossil fuels, oil are in plastic. So this thing with the fossil fuels is really, really big. Plastic,
It's dangerous.
plastic, straws, things that we throw away, plastic bottles, all this stuff winds its way into the ocean. Shoes.
Car tires that you find.
Exactly. I
that
bet
people
you-
are just throwing out.
You think these are plastic or rubber? These are
That's
probably
plastic.
plastic right here. So
Not even metal.
it's a real big issue. So much everything. And I have to tell you one other thing, our food. You go to the supermarket, what's your food wrapped in? Plastic. So we got a problem, right? So we got to start using so much plastic because it uses a lot of fossil fuels.
Wait.
And the fossil fuels, those plastics get into the water, kill fish, et cetera, et cetera. So now we have to make a change. Renewable energy helps us to do that, please.
How about this? The things that you're buying, like produce, things like that, like your orange already has a wrapping, natural wrapping. It has the skin on it, right? But then what you do is, it can be packaged, it can be in a bag of oranges, and now it's in plastic, and then you probably take that bag, how many people put it into another shopping bag? And now you have 2 plastic bags, right? New Jersey's trying to move towards this movement, like California already uses or you have to walk in and actually have your own bag.
No bag.
The Disney store, I was just there the other day, they do not offer bags anymore.
That's
So
excellent.
they give you, for 99 cents, they will give you a cloth bag, okay? But
Big bag.
they are making an initiative to stop using plastics. The same thing with the straws. Okay?
It's called Ban the Bag. This campaign is called Ban the Bag. And what that means is, in many instances, instead of using a plastic bag, you bring your own bag. If you bring your own bag, that means you don't have to use plastic, right? And some places, they'll charge you. If you use a plastic bag, they'll charge you some money. And the reason they're doing that is to get people to stop using so much plastic so we can help to save our planet. So let me go over a couple more things here. And please.
I just wanted to add, if you think about people in countries trying to be aware of saving the environment, not using fossil fuels, 20 years ago in Europe, you carried your own bag. So that's 20 years ago, 30 years ago. So we are just catching up with it. So, so other countries already, you bring your bag to the supermarket all the time, and it's a cloth bag.
Now that's something that you can do right now. You can even ask Mom, Dad, whoever you're with that's taking care of you, if you say, maybe we could use a paper bag over that we can use again, or they have these bags you can buy, or it could be a good project. Maybe you can make a bag, right? And you can use that every time you go shopping, then you don't have to use plastic bags. That's a contribution you can make. You can turn off the lights. Someone said here, you said turn off the lights when you leave the room, right? That saves money for your mother, your parents, your family, whoever's taking care of you, whoever loves you. You can help to reduce their costs and save money, right? To help them out. This is very important. You can do all of that you can do right now. You have the power to do that yourself. All right?
So here's an example of something that's something about the ocean. So I'm just walking along, right, along the shore, and then I see somebody fishing, right? They're looking for a nice, tasty fish treat, and then look what they find: a giant, a plastic bag full of birds and fish.
That's absolutely right. Thank you very much. That's excellent. So plastic is killing the whales. They get fish. The
Wait,
whales
whale.
have plastic in them. Pelicans
Whales are
all over
dangerous.
them.
That's dangerous.
Birds have it all over them.
How is it killing the whales and whales because they're big? They're like
Because they're swallowing it, right? And you don't want to swallow plastic.
Plus, or they get this stuck in their head where they have to breathe through
They
the
can't
water.
breathe,
Yeah,
exactly.
exactly. They're pulled on top of
And
their
they
head.
drown.
Save
They
some
This is
drown.
what's gonna happen to what could happen.
Those things, all those things breathe air. They're like, they're like us. The whales breathe air, but other fish, even those that are fish, they still can die. You can get on the neck, you can choke them, etc. And they eat it. An inverter turns direct current. Can everybody say this? Direct current.
Direct current.
That's DC, direct current. Solar is direct current, DC. So your house runs on something called AC, which is called alternating current. Can someone say alternating current?
Alternating current.
All right. So solar is DC, your house is AC. So now what happens if you go from, if I don't speak Spanish and this person speaks English, what do I need to help me to understand?
Translate.
Thank you. Thank you. You got it. So that's what the inverter does, right? So the inverter takes the direct current and turns the direct current into what?
AC.
AC. And what's AC is alternating current. Alternating current. Great. So that's what your house runs on. So that's how it works. Solar is DC. Direct current goes into your house or the school. It goes through a panel. It goes through something called an inverter, which takes and changes the DC direct current into alternating current so that then we can use it in our building to do things like what? What is it? And it's doing, that's direct current, right? That's how it works. All this current coming through, all these wires, all these things that are being run, right? It's much, much smaller. So what do you think, which one do you think is going to provide more power? Yeah, a whole lot more power, right? But the concept, the idea is the same thing. You see these wires here, just like in the video? that conducts it, you have those wires here. See these wires?
Yes.
So the sun hits this, right? We talked about those electrons being excited. 300 watt module, right? 300 watts. So if this is 60 cells, and this is a 300 watt module, can someone tell me maybe how many watts might be able to be generated by each cell, maybe?
30, 60, 10?
Huh? Yeah. So if you have, okay, so you got 60 cells.
30? 3,600.
Well, let's get, we're almost there. So we got a 300 watt module. We got 60 cells. Where I give it to somebody. How many? Okay, let's do it again. One more time. This is a hard one. You have a 300 watt module. Now someone told me that there's 60 cells, right? So you did something. You said you went across this way, you went down this way, and you got that it was 60. So if this is 300 watts, the whole thing is 300. If there's 60 of these, what do we need to do to find out how much each of these produce?
1,800? 18,000.
How about division?
Oh,
Say it again. Say it out.
We're better
Say it
at
again.
science.
Say it like that again. 5. Exactly. You got it. 5. Well, tell them why. Somebody said 5. Why 5? Why 5?
Because 5 times 60 is 300.
Because
5 times 60 is 300.
you got it. That's it exactly.
Oh, and another way is, isn't 300 ending with a 0 or a 5? Because 5 usually end with a 5 or a 6.
It ends with a 0. This house, say this house has a 3,000 watt system. A 3,000 watt system. 3,000 watts, right? How much is one? Okay, I'll give you this one. 1,000 watts equals 1 kilowatt, all right? 1,000 watts equals 1 kilowatt. What does kilo mean? Kilo. Man, great, you get it. So 1 kilowatt equals 1,000 watts. How many kilowatts is a 3,000 watt system?
300,000. 3 kilowatts.
Say it loud.
3 kilowatts.
3 kilowatts. So I have a 3,000 watt system. I can say this 2 different ways. I have a 3,000 watt system, or I have a 3 kilowatt system. Does that make sense?
1,000 times 3 goes like 3,000.
3,000. And that's 3 kilowatts. Does that make sense?
Yeah.
All right. So now I'm going to ask you this. I have a 3,000 watt system, solar power system on my house. I have this. I'm going to put these on my house. I'm going to use these for my system, right? How many of these, each one of these squares, how many of these are going to be needed for me to do a 3,000 watt system on my house?
3.
Okay, let's say it again. I have a 3,000 watt system on my house. This is a 300 watt module. How many of these am I going to need?
10.
Say it loud.
10.
You got it. That's great. Great. Excellent. Great job. Great
That
job.
would make us 301.
And why is that? Why is it 10?
Because 300 times 10 is 3,000.
Thank you very much. Say it loud.
Negative.
What do you see right there?
Positive.
Say it again.
Negative. Positive.
Okay, great.
Or you need more solar today.
Exactly. So if I want a bigger system, I just get more of these, right? So if I want a smaller system, I use fewer. If I want a bigger system, I use more. That's one of the things that's really great about solar. So I can power something smaller, or I can power a whole building, or I can power literally, technically, I could power a whole city. Or as you saw in the video, we could literally power the whole world with a huge installation.
I just
right?
realized something. Whenever you put a negative and a positive battery together in one battery, it creates a power energy source, but the battery starts moving like crazy.
Okay. Well, we're going to see if that works out. All right, so this is good. We're going to do, let's thank you so much. Thank you. Thank you very, very much. Thank you.
Is that a soccer ball?
So it is a soccer ball. Exactly. So If you put a module flat, you can get sunlight, but it's not going to be as effective because you see over here, some of it's missing the module. Here's the module laying flat. If you hand it straight up, you still get sunlight, but some of it's going to miss. Perpendicular is going to give you the angle that catches the most sunlight, it gives you the most power. That's when we install these. We're looking at ways to maximize, to get the most power we can by getting the most sunlight onto the module.
Did you use the soccer ball for the moon or the sun?
This is going to be the Earth.
Oh, wow.
It's going to be Earth soccer ball. Earth soccer ball. Earth soccer ball. Earth soccer ball.
what's in it? It's not
All right, here you go. So here's a concept for you. So what happens in the winter time that's different than the summertime? The temperature.
The opposite.
But what happens with the Earth?
The Earth turns on a different axis.
Yes, that's true. Different axis, or it's the same axis, but it's called a.
The Earth turns to a different.
It's tilted. It turns in the summertime. What hemisphere? Does everybody know what hemisphere we're in? Do you know what a hemisphere is? All right. If I take this ball and I divide it in half like this, right? So I got a line going right across. This is the northern hemisphere. This is the southern hemisphere. Northern hemisphere, southern hemisphere. Got that? We live in the northern hemisphere, right?
Yes.
We live in the northern hemisphere. We're in the United States, northern hemisphere. So what happens during the summer? Your light blinks.
I think it's running out of charge.
Here we go. So in the summertime, so let's say this is United States, right here. This is the United States. During the summertime, the Earth is tilted more towards the sun, okay?
Yeah, it's like the moon.
And in the wintertime, the Earth is tilting back more. So do you know why we have winter?
Yeah.
Because in the summertime, the Earth is tilting more towards the sun. But in the wintertime, it's tilting away. And what would that mean in terms of temperature?
It goes down.
The temperature goes down or gets colder, right?
So technically this is the sun and this is the Earth. The Earth spins on an axis of at least like more than
spins
a million
around.
miles per hour.
But in the summertime, it leans more towards the sun. In the wintertime, it leans away, so it's going to be colder. Please go ahead.
It's like the moon because like a new moon is like that means the sun doesn't shine at it. Because if we say a new moon, maybe the sun is shining behind the moon. And then the dark side is
There's someone here might even know this. I'll take a guess. Does anybody know the difference between non-renewable and renewable?
Non-renewable is something that you can't keep using again and again, and renewable is something that you can keep using.
You got it. Thank you very much. All the answers are in this room. So we're going to do just a couple more things. One thing they mentioned, the sun is our most important, vital, crucial source of energy. What happened this morning that happens every single day? The sun rises every single day. So we're talking 5 billion years. So we have enough energy on this planet right now from the sun. Great. So PV systems, instead of sometimes saying photovoltaic, sometimes we say PV. Can you say that, PV? PV. What does PV actually also mean? Man, you guys are great. Man, okay. So it converts light directly into electricity using what they call semiconductor technology, which is what you have right here. Semiconductor technology. They said that this is made out of silicon. Silicon is one of the most available resources on the planet. Abundant. Give me that word again.
Abundant.
I said available. I like but. Thank you. Sand. It's made out of sand. It's made out of sand, right? Sand. Exactly. Right. So very available on the planet. So semiconductor material. So here's one of them right here. And it converts, just like we saw in the video there, light into electricity. And this is the outlet. So you got the solar here, the sun, it hits here, you got the electricity being generated, you have the conductors here, and then you have it here in your home available to do things, to help you to turn lights on and other things like that. All right? That's great. Excellent. So they talked about something called photons, which you can't actually see with your eyes, But say if this was the sun, there's photons coming out of here and it's hitting the solar cell. And we talked about the N-peak junction.
Yeah.
And it's not going to lose these electrons. So the electrons, once they move, have electricity. But they find a way to, they talked about these wires here. See this wire down the middle? Because you need something to direct the electrons. So let's say if you have a fire hose or just a water hose, and you have a faucet, what is going to help you to get more water into your garden? Turning on the faucet or connecting it to a hose and spraying your water?
The space it has connected to the both sides so the water can travel through.
That's exactly right. So the water travels right through there. And that's what happens here. So now these electrons are moving. If they don't have anything to conduct them, then they're just all over the place. But now they're going to this wire right here in the cell. And as a result of that, they talked about how it's a continuous circuit. So if there's something that it wants to power, so that's the solar, this is cells right here. There's a light.
Wait, it's turning off? How's it turning off? The light's still on. Look, you're showing me. You're showing me. Look at the light.
Yes, we're going to that. It's the photons. It's those photons. This is our make-believe sun. Make-believe sun. This is the solar cell. These are the molecules, right? So when we shine light on it, right, those photons you can't see, they hit these. We talk about the electrons being excited. See those little metal strips there? That connects the electricity in here on the back. You can see that that's connected. This is connected to this terminal, positive, negative, and all of that. That's how that works, right?
Did you get a chance to see it? Did you get a chance to see it? See the light? Look at the green light. Look here. Look here. Look here. Longest day.
So that's something you're going to be doing. So this gives you a chance to see something about orientation. You're going to have a chance to work with this yourself. So let's get ready to break up in the group. Yeah, please. Question of break the group, please. If there's any tips, we won't have to continue back.
That's interesting. So something that I forgot who said it earlier. Was it you? Was it you? We added the what? We added the voltage. When Dr. Richardson showed us on the page.
What did you?
Right.
Writing what he just learned. And 10 years later, you get the
I need someone to remind me. What are you going to be doing here? Dr. Hillier.
The math, the more, it's called a series, right? A series, when you add more batteries, you add more power.
Because she can see.
Oh,
449. She got 449.
Yeah.
First play, the winner.
Okay.
Let me try.
The winner.
You want to try with 4 batteries?
Amen. Is the winner.
You try with 4 batteries.
No, you went already.
see mine up to.
Okay, so that means the batteries lined up properly.
They actually tell you that I said that.
Okay, let's go. Let's do it. Let's do it. You can do it. No, you can do it. Ah, you see 460? Oh, congratulations, girl. Okay, let's do it.
I think I know how mine works. It's because I put the positive like this close to the negative.
Yeah,
Then it works.
definitely.
Yeah, and it works.
Go a little bit much closer to see the numbers.
Yeah.
Okay, somebody here, you hold one, somebody else hold one.
What? How much did we get?
This is how you do it. Let me show you.
Just 5? Okay, I think 5.6.
I think it's gonna be 6 something. I don't know.
Okay, 6 something.
Very hard.
It is hard, yeah. You want a partner, so get a partner to help you. Pick a partner.
And I picked 2.
Okay, now Jocelyn, you're gonna do 1 on this end. You can do it, you got it. And then 1 on this end.
Can I be the one? No, I think you like put
Wait.
your hair. I think it's like your hair.
Come more back over here, okay?
I think you like put it on the side.
Yeah, try to stand it up. Jocelyn. Okay?
Thank you, Jocelyn.
Alright. Keep it on there, don't move it around, just keep it in one spot. They must be doing something wrong. There must be a disconnection. I see a disconnection. Where's the disconnection? Here. And the batteries. The batteries are not connected. Okay, here we go. Ready? Are all batteries connected? I'd say probably 6.2-ish, 6.3.
I think 6.30.
Okay. Yep, sure. Okay. So pass it around. Be gentle. Hold it from the bottom, just like. Okay, but facing the other way, so that the panel has to face the light. Yep. Good job. Being gentle.
Then what we're going to do is
Now try to angle it down. Down. No, angle. No, with the way you're holding it. So just change the way you're holding it. So like it's going faster or if they go down?
If you
put more batteries, it will double the power.
will it always double the power or just increase the power? Excellent. Okay. It'll double the power if you add how many batteries? Double. Excellent. If you do 4, it'll quadruple the power.
Actually, I just noticed something.
Hey.
They're just riding and I'm just standing here like watching
Because they're contributing to the conversation. You sitting in the corner, you're not. Come on, man. We need your help. All right, sit down right here.
20 minutes later.
Yeah. It wouldn't be 20 minutes later if you helped out. It'd be a little bit faster.
No, like what they do in the show. 20 minutes later. You put more batteries. 5 hours later. 5 hours later. 7 years later. 55 years later. Till he died, yeah. So I live forever. 90 years later. It will 10,000 years later. And a trillion years later.
So the sun exploded.
Years later. 1 trillion years later. The sun exploded. The energy of
writing what he just learned.
Okay. You have 1 minute. Hurry up.
Hurry up, guys. 1 minute.
What did you?
Right. Right.
Naomi, right?
Yeah.
Excellent. All right, Naomi, share something that you've learned or your group learned today in the solar tilt activity.
I learned that when you put the light on the panel, the fan spins.
Okay, did you all hear that? When she puts the light on the panel, what happens to the fan?
It spins.
All right, so is she accurate?
Yeah.
Everyone saw that?
Yeah.
Okay, excellent. Good. Do you want to share anything else or good?
Yeah.
Okay.
And when you tilt the fan, like it spins even more faster, and it makes a big vibration.
Okay, so something about tilting, and then you felt a stronger vibration?
Yes.
All right, excellent, good. Yellow group volunteer. Thank you, Naomi. All right, go ahead. Something that either you want to read off the paper or something that you learned right off the top of your head from that activity. Go ahead.
So I like when
Not me, your crowd.
when we put the light on
Solar panel?
the solar panel, when it was closed, it went fast, the fan, but when it was going when we were separating it, it was going slower.
All right, so let me get this right. You're talking about distance from the solar panel and the light? Okay, excellent. Keep going. Anything else? You can stop there. Excellent. Good. Thank you for sharing. All right.
Yes.
You all saw that? All right. So it's got to be true then if everyone else saw it, right?
Nobody wants to sit on that.
Anybody from the blue group? All right, come on up. All right, again, let's go. All right.
The more closer the light was to the fan, the faster the fans spun, and the longer the light was on the longer the light was on, the hotter the solar panel got.
Oh, okay. So now we're talking about heat conduction, or in this case, radiation. But yes, awesome. All right. All right. That is.
The more the energy.
All right. So are you associating the fact that because the fan spun faster when it was closer, there was more energy involved? Okay. And then next one.
When you move the solar panel away, the energy decreases.
Okay, so again, with the direction and the way it's facing, if we're moving around, we might not have direct energy being focused on there. Awesome. Anything else? All good? Awesome. Give them a round of applause. Okay, so the meter gave you a higher reading of the amount of voltage that was in there, but with all the batteries. Can you remember how many batteries your group had? 4 batteries? Okay.
What do you call that? When I have several batteries, what do you call it?
Yeah, when the batteries are lined up in series, that means they're lined up kind of like a train, right? All right, so you want to make sure that you remember this name.
Power goes up. Example: 2 batteries is 317. 2 batteries is 317. 3 batteries is 4.7, and 4 batteries is 6.7. I noticed that we put the batteries together, the number changed by ones, and then the last 4 batteries it was doubled. And power 2 equals 3, and power 1 equals 2. How do you know so much? The power 1 equals 1, sorry.
Good. So you're assuming that now that if I put 1, it didn't equal 1, it equaled a little bit more, right? And I believe in the diagram we also saw that it was 1.5 volts. So every time you add an extra battery, you added 1.5 volts. I did something in my group. I shook the table a little bit. What happened to the numbers when I shook the table? They moved around, they weren't sturdy, right? So some of our numbers might be a little bit different than other groups, that's fine. But there was a little bit of movement and your numbers changed. Okay, so you have to be a little bit careful. All right, awesome job. Thank you.
That meter, I read what the name was, but I don't remember.
Multimeter? Multimeter.
And what was it actually measuring it? Did it depend what your group was?
Exactly. So we're measuring voltage, you can measure voltage, you can measure amp, other questions related to, there was a question about solar storage. So we did two things. We talked about solar and batteries. So the solar power, we know, is impacted by the sunlight. So the sun shines during the day. But what happens at night? There's no sun, so you can't use solar power. When you have a battery, do you have sunlight or need anything else for the battery to work?
No.
So you can take a battery, it's portable energy. I can take a battery, I don't have one in front of me. You can carry a battery with you, right? You have portable energy, right? I can take the battery, I can plug it into something, and it will run. So that's what batteries do. You have portable energy. But the other thing that batteries do is they store the energy, or the electricity, right? So you can take now, what's happening in solar is a lot of houses, well, let me rephrase it. It's beginning to happen more. It's early stage, beginning to happen more. You can store the electricity in batteries. It makes it more expensive, but the prices are starting to come down. So we think that in the future, most solar or a lot of solar will be done in combination with battery storage. Right now it's mostly solar, singularly by itself, and then sometimes every once in a while people have little storage. But we think in the future that's going to increase because battery prices are coming down. So then you're going to have, during the daytime, you have the sunlight shining, giving you power, and then at night, you'll be able to pull a lot from your battery. There's something that you do now, even if you have solar without batteries. You have a built-in battery. Does anyone know what an electric company is?
No.
They send the bills to your house. You get electric bill every month? It's an electric company. They send the bills. So if you go outside and any place you'll see wires, right? You see all those wires? There's a big company in almost every city somewhere that produces electricity, and they send that electricity through the wires, right? It's called the grid. The grid. And that is how we get power from this building. That's how you get power to your home. At nighttime, if you have a solar power system, you get power from the grid, right? So the grid, the electric company, kind of acts like, sort of like a battery, if you will. So at daytime, if you have solar, you get it from the sun. But at nighttime, you're going to get power from the grid. And one of the things about that is that it's going to bring your cost down. Solar produces power during the day when you're going to have the most expensive electricity, and then you pull the electricity from night when it's lower. And your goal is to balance.
And then you make money.
That's called net metering. Net metering. And so what happens is you produce electricity, and then you actually get paid. You get a credit in most instances from the utility company, right? For the electricity at what they call retail rate. So basically, you're producing power when it costs the most during the daytime. They're giving you a credit. If you produce more electricity than you use, it goes out of your house and into the grid, and then the electric company can send it to other people, right? So that's what net metering does. It gives you a credit. It's really important. It's one of the things that's helped solar to grow a lot, having net metering. Any questions? You all have been incredible, fantastic, fantabulous, wonderful. It's been an honor to be here with you. I've enjoyed it tonight. You all are so bright, smart, wonderful.
And here's something that we wrote. So here we have that I learned we had to change the meter to get a good heating to see what the number was in the meter. So we
Okay, wait. Let me talk because I need to go. Okay, guys. So we learned about recycling, and you should always recycle because it mostly goes to the ocean, and you don't want it to go to the ocean because the fishes die, and we need those because we can live. So if you want to live, you need to keep the planet good and healthy, like your bodies. Thank you.
in Florida, and in Florida, in Florida,
They cost $1.
like the bags, they cost like 99 cents or $1. So people they usually, your parents want to save up money. So what you can do, like if you
if you wanna like don't want to buy a bag, you just make your bag. You just make a regular bag. So for it, the bag can probably be for a science project or for shopping.
So I would just buy a normal shopping bag and that you can use that like it's not gonna rip or anything, so you can just use it. And if you ever throw it out, it's gonna go to the ocean, but you should never throw it out because it's gonna be healthy for the environment.
So now here we have another guest. Here we have another guest. What did you learn today?
If you have like lots of batteries all together, you can make more voltage, energy.
So today we learned like. So today we learned like if you put negative and positive, it will work. But if you put it all together side, it will not work. So I learned that when you put the positive and negative in testers on the positive and negative battery, the first one was 3.17, the second one was 4.17, the third one was 6.24, the fourth one was 6.11.
So Naomi,
And I was surprised at how much our measurements increased each time.
I liked how the batteries made the voltage, and when we put 4 batteries all together, we made more voltage, and also when we tried with the fan, when you put the light bulb closer to the solar panel, it made the fan go faster.
So and then we have like some people who like they explain what they did, and they also drew their pictures. So like the sunlight is on like the panel, and then the panel, the sunlight on the panel, it makes the fan spin, and then the sunlight like right here is another picture of the sunlight, and then it's like standing. You hold it from right here, and then there's the panel, and then when you tilt it, the fan moves slower.
2, 3, yellow! Wow, this thing is excellent.